So 2.1, relations and functions. So this whole chapter is about linear relations and functions. What does it mean to be linear?
Straight.
Straight, because it's a line. So we're talking about lines. Relations, how things are related to each other, and functions, how x depends on y. Yes? They're out there by Dylan.
Okay.
Cool. Make sure you grab a lesson plan. All right, 2.1, relations and functions. During the hot days of summer and fall, we see a relationship between the time of day from the temperature and the temperature. In general, what can we say about the temperature as time of day goes from morning to noon to afternoon? Wait, what are you laughing at now? I don't know.
Cold, hot, hot.
So it starts cold, and it gets warmer till it reaches hot. Super hot heat.
And it
Height.
stays hot.
Okay, so what can we say as time increases, right? We go from like 8 a.m. to 11:30 a.m., right? As we get longer in the time, guess what happens? As time increases, temperature increases as well.
On average. Not always, right?
Well, this is in general, right?
Yeah, in general.
In general. Okay.
Oh, there.
So can we predict a relative temperature for 2 o'clock this afternoon?
No.
Yes.
Doesn't it get colder at night?
Well, at night, but I was talking about like, pause. We're talking about morning, 6 a.m. to noon when you eat your little lunchy, and then when you get out of school. So it mostly, like, for the most part, it gets hotter. As time goes on, it gets hotter. That's the relationship. So can we predict, maybe it was 60 degrees this morning when we woke up, about 2, maybe it's 100 degrees. But then what happens? Will it be hotter or cooler at 11 o'clock tonight?
Hotter.
Cooler.
Cool.
The little face.
Nice.
Such a troll. Okay, cool. So it'll be cooler at 11 p.m. Cooler at 11 p.m. Right? So you guys have this like knowledge inside your brain about this relationship between temperature and time. You're like, okay, cool. Guess what? It's night. It's going to be colder. Oh my gosh, I'm in California in almost end of September. It's 100 degrees. It's super hot as time passes. It gets warmer throughout the day. Okay, if we call time x and temperature y, we have an ordered pair, x, y, which represents the relationship between time of day and the temperature it is at that time. When we have a set of data, we have a relation. And of course, you already know that these ordered pairs may be graphed on a graph. So first, a blank is formed by the intersection of two number lines, the horizontal axis and the vertical axis. What do we call this XY graph? Coordinate plane?
Axis.
Coordinate plane?
Coordinate plane.
Yeah.
Coordinate plane.
It's a coordinate plane. Coordinate planes have 4 quadrants. Hey. Okay, so notice the plane containing the x and y axes is the coordinate plane.
Nice.
Next, a blank is a set of numbers or coordinates written in the form x, y. Oh, wait, what? Who said this? Ordered pair. It's like I read it to you before. Ordered pair. An ordered pair is a set of numbers or coordinates written in the form x, y. Okay, so just in general, so this is quadrant 1 up here, right? And we write Roman numeral, and the x, y, it's going to be positive in both of them. This is where both of them are positive. And then we go around counterclockwise. So here is quadrant 2. I have negative x but positive y. Down here is quadrant 3. So notice how we wrote Roman numeral, quadrant 3, and it's negative. Both x and y are both negative. And then lastly in quadrant 4, so quad 4 is IV, that's 4. Because V is 5, 1 is, the little 1 is 1. Oops, I don't know if the V was not clear. So if you put 1 in front of 5, it subtracts. So if I put Vx, oh, that's literally half of 10, that'd be 5. Whatever, you don't need to know Roman numerals. Okay, so this is y is negative, x is positive. So those are the 4 quadrants, etc. Shake your head a little bit, get the cobwebs out. That was entertaining, thank you. All right, so the x value called the blank represents the horizontal placement of the point. It's the x coordinate, it's the left or right. So the x coordinate So the x value is the x coordinate. It represents the horizontal placement. So this is left or right. And then the y value is going to be the y coordinate. And this is the up or down. Up or down. Up or down. Okay, cool. So a set of ordered pairs. So not just like one x comma y ordered pair, but if I have lots of sets, guess what? The set is going to be called a relation. And a relation, see, it comes right after we define it. A relation can be represented in several ways as an equation, right? Y equals 5x plus 2. It can be written in a graph. We can have a table or mapping.
Nice.
So, do we remember these? Maybe not. Like, if you don't remember, no worries, because we're just going to go over them again. Perfecto. Okay. So here are different things: ordered pairs, a table, a graph, mapping. So this first one, a blank illustrates how each element of the domain is paired with an element in the range. So first we're going to deal with mapping. A mapping illustrates how each element of the domain is paired with an element in the range. Okay, so wait, what's domain again? What's domain? The x values. Awesome. And range is the y values. Perfect. Okay, so let's talk about the x values of my domain. So the domain are all the x values I have. So, of course, I'm just going to write them down. -2, -1, 0, 1, and 2. I'm sorry if this is a lot of writing. We'll get through this together. We can do breathing exercises, get our chakras in line. Yeah, I don't know. I've been getting into yoga lately, so
Miss Hoffman.
that's cool. Okay. Yeah, she does yoga. That's true. Just want to give you time to make sure you write this down. Okay, so we said domain, x values, range, y values. So then I can write my set of y values. Literally all that means is the y values I care about. The y values I have in my relation. Notice that this is not all numbers between 4 and 8. It's literally 4, 6, 8. These are discrete points. It's not continuous, a nice little line that's continuous. These are discrete points. Just to be clear what this is. Okay. Do you have questions so far? Look at you. 2 pages of notes down. High five the person next to you. Okay, cool. Yeah, you guys are like doing math and stuff. It's great. Okay. Yeah. Okay, now let's express. So the reason I go through this whole vocab thing, it's so we have a common language. So when I say a relation, you know exactly what I mean. And if you don't, just go back in your notes and be like, yes, that's what a relation is. A relation is a set of ordered pairs. All right. So now let's go through example 1. Express each relation as a table, graph, and as mapping, then determine the domain and range. So first, we got a bunch of ordered pairs. So I can write it out as a table. So I'll go 4 is my x, 3 is my y. I got that one done. And then I see I have -2, comma, -1. So I'm just writing it out as a table. And then I have 2, comma, -4. Awesome. And then 4, comma, -0. Cool. So I wrote it as a table. Now if I do it as a graph, I'm just going to plot those points. Do you guys feel confident being able to do this yourself? No? Yeah? Okay, cool. So let's go ahead and do it. So I go over to 4, up to 3. I draw a point, and now I have a point at 4, 3. -2, comma, -1 is down here. 2, comma, -4. And go ahead and plot these, and then if you you can like check it out and make sure you're correct. And then this is 0, comma, -4. Just double check your answers. All right. So let's go ahead and let's map. So I have all the x values I have are 4, -2, 2, and 0. Those are my domain. Those are my x values. And the important part when you are mapping, you have to know you do not repeat the values in each column. Do not repeat values in each column. All right, so what I mean is, hey, the range, I have a 3, I have a -1, I have a -4. Oh, I actually have 2 -4s, right? You see in my table, the bottom 2, I only have to write this once. And then to finish out my mapping, I'm going to draw some arrows. So my x4 corresponds to my y of 3. My x of -2 corresponds to a -1 y, right? That's -1's in my range. And then both 2 and 0 map to -4. That's why it's called mapping, because you're mapping the pairs. What does x go with? What does y go with? And then lastly, if I wanted to write the domain and range, that wouldn't be too bad. We just list out all of my x's. And to find the range, I list out all of my y's. And notice I only write -4 once, because I don't need to repeat it. Just because I have 2 x values that go to it doesn't mean I have to repeat it. Cool. So it seems like we're getting it. So is it cool if we skip the next one? How we feel? Silence. This is so weird. This is so weird. You guys are like the non-talkers. Except for like Dylan and Ashton when they fight. And then A period, like I can't get them to stop talking. Cool. Okay, so we don't necessarily have to do this one. I feel like you guys get the gist. We can just keep going. Awesome. All right. In a relation, the value that determines the output, right, the thing that's affecting the output is called the independent variable. And these are mostly the x values. So the first line is we're going to put independent, and these are normally the x values. So independent goes on the x-axis. So in science class you learned this. Talia, sit up please. So independent variables are on the x-axis. What's on the y-axis? Dependent. Okay, cool. Do you remember doing these before? Awesome. Okay, so if you remember, perfect. You should feel happy. This will be a great chapter for you because you should get an A. If you don't remember, perfect. We're going to review. You should get an A. Okay. Identify the independent, dependent variables for each situation. So in warm climates, the average amount of electricity used rises as the daily average of temperature increases and falls as the temperature decreases. So I see two things. I see electricity use and temperature affecting each other. But which one's the independent? Which one determines an output? Which is the one that things are dependent on? Temperature, right? So depending on the temperature, we can see how much electricity will be used. The amount of electricity depends on the temperature. Like right now, my electric bill is horrible because it's 100 degrees outside. If it was an actual reasonable temperature of 60, I would use less, right? The amount I use depends on temperature. How do you say another way to say it? Like, what's another way to say depends on? Relies on?
Dependent.
Well, I'm trying to use not the word depend. Rely. But like, we wouldn't know how much electricity if we didn't know how much temperature. So for instance, if I locked you up in a room, shook you up, whatever, and you have no idea what time of day it is, you would have no clue what like temperature it is outside. Versus if I say it is, 7 a.m. in Southern California, you'll be like, okay, well, it's probably gonna be around 70 degrees or so. So knowing the independent will tell you can like predict how much the dependent will be. All right, number of calories you burn increases as number of minutes you walk increases. Two things I see, number of calories burned and number of minutes you walk. So which one affects the other? Do we have an idea? The number of minutes you walk is what? Independent. Number of minutes walked. And then, so as a direct consequence, we find out how many calories. In order to find out how many calories you burn, you have to know how many minutes you walked. But I don't have to know how many calories I burned to know how many minutes I walked, right? So the independent, you only have to know that one. But dependent always relies on something else. So the calories you burn would be the dependent. All right, so let's use this graph below to answer the following. Name the ordered pair at point A and explain what it represents. Should I just go down the list? Yeah, let's start at the bottom. Miranda Frank, what is A? Explain what name the ordered pair and then explain what it means.
A is 120.
Yep, 1 comma 20. And what's it represent?
It represents
Close. On day 1, because remember, the X is my day. On day 1, it means the average temperature is 20 degrees Fahrenheit. Ashton, what about B?
Name the ordered pair at point B and explain what it represents. Point B. So it's 40 degrees and it's on the 6th day. That means that the 6th day is really hot.
6 comma 40, that's the ordered pair. And then that means on day 6, average temperature is 40. It's not hot at all. That's actually just right above freezing.
Well, it's hotter than
Hotter than 20. Okay, so let's identify the independent and dependent variables. Elizabeth, what is the independent here? Exactly. Exactly. In order to figure out the temperature, it depends on which day we're looking at. But we don't have to look at the temperature to figure out which day it is. That was a weird thing to say. What about, Isabel's not here. Jesse, what's the dependent? Hopefully. So if the independent is the day, the dependent, so independent always goes with x-axis, x. Yeah, it's just temperature. Temperature, perfect. Let me pause here a second. I really value your input. Is this going too fast? Is this about right pace?
Way too
A
slow.
little too slow? Okay.
I think it's fine.
Is it okay? I just don't want to be going, I don't want to go too
I
fast.
think any
I just don't want to go too fast. Let's be kind. We don't tell each other shut up. We just ask them to politely stop moving their mouth.
Okay,
Don't say that.
okay.
Oh. No, you shouldn't say that. Okay, cool. So the next thing we're going to talk about, a blank. So that was all about relations. But now we're going to talk about functions. All right, so relations, we say, okay, there's a bunch of data points. Maybe there's some correlation in them. Maybe not. We don't know. But if we have a function, we can see a relationship between input and output. So all functions are relations, but not always, the opposite is not always true. So fill in the blank is function. A function is a relationship between input and output. Awesome. So if you work a minimum wage job, how many hours you work depends on how much money you get. So your input is number of hours worked, and output would be how much money you get. So you don't know how much you earn unless you know how much you worked, right? So those would be independent and dependent. In a function, there's exactly one output for each input. You cannot have the same value going to different y values. So a function is a relation in which every element of the domain of the x is paired with one of the range. So remember the mapping earlier, we had two x's going to the same y? That would not be a function. Each x can only go to one y. All right, determine whether each relation is a function. Who did I leave off on? Ruby, is this a function? Example 3, page 5.
Yes.
Yes. Okay. Y.
Is it A?
Yeah, sorry, 3A.
Yes.
Why is it? You want to explain?
I know.
You know that you know.
Because
It is a function, yes, because no x value.
there's not more than one y going to it.
Exactly. So we say it's a function because no x value goes to different y values.
Yeah.
Right? So every x goes to a different y. There's not one y going to two x's. Or sorry, there's not one x going to 2 y's. Each x only has 1 y value. So an example, if I would have something like this, that would not be a function because now I have 1 x value going to 2 y values. But what I want is each x can only have 1 y value. Lauren, what about b? Would this one be a function? So I'm looking at x2, 3, 3, 4, 5. Uh-oh. Exactly. No, not a function. We have the same x value to 2 different y. Goes to, how about matches? That's a better verb. Matches with 2 different y values. Okay, next. Eli. Yeah.
That is a function
Yes, why?
because there is exactly one output for each.
Yep, and x values don't repeat. Exactly. They do not repeat. X values do not repeat.
2 outputs for 1 input, right? No. No.
No.
Other way.
Right.
Two.
2, I could have the same y value for all of my x's, but I can't have more than 1 y value for a single x. Yeah.
2 inputs for 1.
Yep. Awesome. Okay. Woo woo. 7? No, okay, cool. It has. I've taught 5 classes. I proctored an exam during lunch, and I was helping people during bonus. So I'm just like, I haven't had coffee today. I can just crash. All right. If you need to, like, literally, if you were like, you know, whatever, need to fidget, need to stand up, whatever, instead of like leaving the room, you can just like stand up, go to the back, walk around a little bit. I don't mind, but I want you to like be part of class, be really present. All right, once again, here's a little vocab, just making sure we understand what does Miss O'Brien mean when she says that. Oh, yes. So when I say a graph that consists of points that are not connected, what type of function is this? Do we know?
Yeah.
Discrete. Discrete means discrete. Distinct single points. Distinct single points. I could have a graph that looks like this. It doesn't even matter if they're in a line or not. Literally, this is still going to be discrete because they're points that are not connected. They're separate points. This is still discrete. Versus, if we look below, I wonder what it will be called. A function graphed with a line or a smooth curve is a... let's see. At the end of all the Marvel movies, they're like to be continued. So if it has a smooth curve, it's continuous. It like just keeps going, nice and smooth, all connected. Continuous. Continuous function. So these are 2 different examples. So notice this was 1 page of notes. My bad. I just wanted you to like have an example and like see visually. Continuous. Notice it's like we have a billion bajillion points that are all connected and there's no holes. I could pick.
Someone say holes?
I mean, can't you just draw a line on the discrete one?
And then we could make it a line, but for example, discrete, if you want to know how much money do you spend at a grocery store if you're buying apples. Okay, 1 apple is $5. Wait, that's crazy.
That apple better be like
I'm sorry. How about we're buying packs of sugar. A pack of sugar, 2 pounds. 2 pounds of sugar, $5. What if you buy 2 pounds of sugar? $10. Oh, wait. So it's not just a smooth continuous, right? Per bag, it increases the amount you pay by these little dots. Versus if you go to like this farmer's market and you're going to buy like curry and you pay per gram and they like weigh it, you could have like, 0.457 grams. Cool, I have to pay for every 100th of a gram. Like, this is so dumb, right? So that would be more continuous if you can like choose exactly how much sugar you want versus these pre-packaged bags would be more discrete. Okay. Somewhat. Okay, do I want to do this one? Yeah. 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 Dylan says, yeah, let's do it. Woo! There are 3 lunch periods out of school. Yeah. If you go to a big school, they have to like stagger it.
Oh yeah.
What?
I forgot.
Yeah, all at the same time.
If you have 4,000 kids at a high school, you can't be like, oh, we're all on lunch. Like, what? Good luck going to the bathroom. That's crazy. Yeah. And normally there's like cafeterias and you go through like a lunch line, whatever. During first period, 352 students eat. During second, 304 eat. During third, 391 eat. So make a table showing number of students for each of the 3 periods. Each of 3 periods. So I have 3 periods to talk about. Period 1, 2, and 3. And then I can go through and fill in how many students there were in each period. 352, 304, 391. Okay. So if I want to go through and list out the domain, these are the x values. Well, that makes it pretty clear. It's just 1, 2, and 3. And then the range. This is discrete because I only have 3 points. I have period 1 has this many students, period 2 has this many, period 3 has that many. So my range is going to just be those 3 y values, 352, 304, and 391. So notice in class so far, like I didn't make you go in order, right, numerically, smallest to biggest when I was listing out the range. If you wanted to, that would make me more than pleased. It would make it super easy for me to grade, but you don't have to. Okay, write the data as a set of ordered pairs, then graph the data. So a set of ordered pairs, well, 1, 352. I also have 2, 304. And lastly, I have 3, 391. Those are my sets of ordered pairs. So I have to graph them. Normally, domain goes with x. So I'm going to label my x's the period. Right? Domain is the period. That's my independent. 1, 2, 3, 4. And then my y is going to be number of students. That's my range. So I can start at like 300, maybe go by 325. 25, 350, 375, 400. I think that will bring us all together. We can have all of our numbers on here. So this is just standing for number of students. So one thing I want you to note when we graph, we have equal spacing. We have labeled axes. Wunderbar. All right. Give you a second to finish writing this. Don't want to skip ahead too much. Do you have your notes? Don't you? You need to be following along. Okay. Even if you're like super Gucci with this, you already know it. Whatever. Just follow along and follow along. Right.
But I bought the pants.
Bought the pants?
Gucci. It's a joke.
Super impressed. Okay. Period 1, I go to 352, which is about right here. Period 2, 304, which is right above 300. And then period 3 is at 391, so it's really close to 400. Okay, and then we can talk about whether this is discrete or continuous. What do you think, Dylan Bookbinder? Discrete or continuous? Why? It's not connected. It's literally just 3 points. That's it. It's not connected. Exactly. They're not connected. They're literally just 3 points. It's discrete. Discrete are just like, huh? Yeah, you were correct. It's discrete. Sorry, I like circled it, but I should write it. It's discrete because it's just 3 points. They're not connected. Cool. If I'm ever going like too fast, just be like, whoa. Cool. Right, so this like one problem just took up a whole page, and then the discrete versus continuous is just a whole page. But now if you like go home, do your homework, you're like, oh my gosh, I forgot what discrete means. Okay, cool. So we have a problem, really digging into it, examples. All right, I think it's enough people. So we just have a couple more pages. To see if a graph represents a function, you can use the blank. Vertical line test? Hey! Dylan, brilliant. On the ball. Gets a point. All right. All right. To see if a graph represents a function, you can use the vertical line test. It's like I wrote it underneath this. I did write it underneath. Vertical line test. If a vertical line intersects the graph more than once, it's not a function. So I can just draw a little line. Like this is a function. Check it out. Every one of these little lines I'm drawing only touches one point of my graph. Do you see these lines? Okay. Versus if I draw my lines here, ooh, I touch it twice. I touch it twice. That's not a function. But if I touch it here, oh, every single one of these only touches one.
Oh.
Yeah. I don't remember. That was a long time ago.
Wait, how is the
So-
first one not touching 2 points?
The first one?
I mean, how is the first one touching 2 points and the second isn't?
So this one, at this point, you include this one, but open circle means you don't include. This would be the only point where you could potentially overlap, but you don't. Remember how we were graphing inequalities? Open circle means you don't include it. So I only have one x value, one x value, one x value, one x value. This is the one point where maybe I could overlap, but it doesn't because it's open circle, and then I just have one x value, one x value.
Oh.
So I'm doing a vertical line. Sorry. I'm drawing these arrows so you can how many times do I cross the function? How many times do I cross the function? All right, so does it cut across the graph more than once? If not, it's a function. But if yes, it is not. Just to summarize what we said. All right, and then check it out. I even have one more example for you here. So we can go through and determine whether each relation is a function. All right, so remember, functions have to pass vertical line test. So we'll circle yes or no. Let's go with Dylan Benson A. What is it? Well, I do the vertical line test and I cross it more than once. So it's a no. But if I look at this next one, every single time it's, okay, imagine I'm putting my pen across. Put your pencil across. Do you cross the line more than once? Nope. Let me move this over a little bit. Nope, still only touch at one place. Still only intersect one point. Only intersecting one point. Only one intersecting one point. Okay, cool. So this is an intersect. This is a function. But here, it's because it touches twice, it crossed it twice, that's not a function. All right, let's go with Talia C. What do you think? Is it a function? So if I draw a vertical line, I only cross it once. Vertical line, only cross it once. Vertical line, only cross it once. Wait, what did you say? Did you say yes or no? Ooh, what do you think now? Yeah, it's a function. It's a function because does it cut across more than once? If it doesn't cut across more than once, it will be a function. If you have 2 or more times touching, it will not be a function. Okay. Next one, let's go to Miranda. Is this a function? Why?
Oh, wait.
It's not a function.
Yeah.
You're right, because
It's not.
because those 2 points right there, they have the same x, but more than one y. Bingo, bingo, bingo. All right, so equations that are functions can be written in a form called function notation. And I think we've already done this, but it's a good little review, especially with chapter 1. I had you guys do it. Function notation. So an equation has a y equals blah, 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 but a function notation is f of x equals blah, blah, blah. So here, it's literally the name of the function and then the input. So let me be clear about that. So this is the name of the function. Name of the function. All right, so f of x, I could have a g of x, h of x, it's just the name of the function. And then this x, whatever's inside here, is going to be the input. All right, In a function, x represents the elements of the domain, and f of x represents elements of the range. So f of x means y. Cool. The graph of f of x is the graph of the equation y equals f of x. Awesome. So if we want to find f of 5, what you do is you substitute 5 in everywhere there was an x. Cool. Is this last page? Close. Super close, yeah. Okay, so let's just go through these. Let's do this. So f of 4 means I'm going to plug in a 4 everywhere where there was an x. Perfecto. 12 minus 4 would be 8. I'm going to give you guys, about maybe 10 seconds or so. Let's try B. If you've not already, I want to see you working on B.
2? Or are we not solving for
So this is not for f. It's f of 4. This is function notation. Yep. Because this is f of x. So here, f of 5, because f is the function name. So this means I'm putting in 5 everywhere there was an x. So 15 minus 4, it would be 11.
How did you get 3?
Where? So I'm plugging it into this equation.
Why did you put 3 for
I didn't. So f of x is 3x minus 4. So if I do f of 5, everywhere there was an x, I put a 5. I didn't put 3 for x.
Oh, never.
If I do f of negative 3a, that means I'm going to plug in everywhere there was an x. Now I'm going to put negative 3a. Because I'm still plugging into this one equation. What is 3 times negative 3a? Negative 9a. Exactly. Negative 9a minus 4. Awesome. Let's do E first. Let's do E and then we'll go back to D. What is f of c? It'll just be 3c minus 4. You just plug it in instead of x. Yeah. Okay. Let's try part D. F of n plus 1. So literally whatever's inside here, that's where we're going to plug into x, into the equation. So I put this in place for x. Remember, it's 3 times x. So 3 times n plus 1 minus 4. And what do I have to do with the 3? Distribute. Oh my gosh, on the ball. All right, distribute 3n plus 3 minus 4. I will get 3n minus 1. Cool. And lastly, let's try f. So here, I'm literally taking f of negative 6. I'm plugging in negative 6 in place of x. And then I'm going to be adding 10 to it. So this right here was f of negative 6. So I have negative 18 minus 4 plus 10. So this is negative 22 plus 10, negative 12. Awesome. Awesome, awesome. And then, this is just a little review. Identify which are functions. So now we can do rapid fire. Let's do Ashton, then Elizabeth, then Isabella. Isabella's not here. Ashton, Elizabeth, and then Jesse.
Again.
Ashton, how about this first one? Is it a function?
Yeah.
Yeah. Elizabeth, what about the middle one? No, it touches more than once. No. Jesse, what about this one? Does it?
Oh, yeah.
It is. Woo! It is. Okay, let's do the next one. So, Ruby, walk us through how to do A.
Plug in the negative 2 with all the x's, so you get f negative 2 equals 2 times negative 2 squared minus 3 times negative 2 plus 1.
Exactly. And then we do order of operations. So negative 2 times negative 2 is 4. So I have 2 times 4. Negative 3 times negative 2 is plus 6 plus 1. So this is 8 plus 6 plus 1, so 15. I'll pause a second to make sure we understand Like, let's see if there's any questions. Okay, cool. Now, we can try the next one. But this is a tricky trick one, all right? I'm just going to warn you, a little tricky trick. And I think you'll see what I mean. So, Lauren, what should I do for B?
So 2 times 3a times b squared minus 3 times 3a plus 1. So you're going to do 6a
Close.
of b squared.
This is why I said tricky trick, because you distribute the square, which means I'm going to have a 3 squared and an a squared. That's the trick play. That's the trick play right there. So then I have 2 times 9 times a squared minus 9a plus 1. So I have 18 a squared minus 9a plus 1. So chapter 5 is when we like explicitly talk about rules of exponents. But since I know you've done it before, I wanted to make sure we understand, because there will be some problems from the book with the square. So you have to distribute the square. Remember, 3 squared is 3 times 3, which is 9. Cool. And then the last question. It's just, here's volume of a sphere. Right? So this little function, v of r, volume, depending on radius. So if I input a certain radius, I can find out the output will be the volume. So 4/3 pi r cubed to find v of 2, all that means is I'm going to plug in 2 in place of r. 2 times 2 times 2 is 8. Okay, so 4/3 pi times 8, well, that's just going to be 32 pi over 3. And what this does, it represents the volume of a sphere
Wait, where did we get?
with radius of 2. Awesome.
Wait, why do you have the pi up?
It is, oh, sorry, cubed. So it's 4/3 times pi times r cubed. So if I have 4/3 times pi over 1, that's still 4 pi over 3. That's just, yeah, just to make sure we're all clear with what I did. Okay, thank you so much for your guys' attention. This was great. Notice 15 through 19, you're only doing the graphing portion. Like it says, it asks you like 3 different questions, just graph it. But you will need graph paper, so I tried cutting it down so it's relatively short. So you'll need graph paper for this chapter.